So starting off nice and simple, positive versus normative statements. Positive, these are things that can be tested, the things that you say something about the environment, versus normative are subjective claims. Look for things like should, could, you know, I should go eat steak would be an example of that. Okay, so supply and demand. At the intersection of those two, we have our equilibrium, also called as a market clearing price, where everything that wants to be bought and everything that wants to be sold happens. So it clears the market. Demand's going to be downward sloping. Supply's going to be upward sloping. Little review from micro there. And just keep in mind that there's a difference between quantity demanded and demand, and quantity demanded and supply. So there's a difference between the actual function and then what is happening. And then once supply equals demand, so you're at equilibrium. And this is where they intersect. And just one thing to keep in mind is the changes of demand. So like technology preferences, those things, those shift the demand curve, versus a change in price just moves along the demand curve. And similar things for supply. So changing that price moves along the supply curve. Changing things like price of substitutes, complements, technology, those actually adjust the actual curve and move it left or right. So how do we make things? This is done through the input of capital and labor. So we take this, put it together through this function, and then we have a certain output. And these output functions can vary in terms of styles. Some can be linear, some can be exponential, whatever it is. But we take these inputs, capital and labor, and then we have put it through this little factory, and then we get output, which is quantity. And labor, this example of like time, people, human capital, and in the short run, this is going to be a variable. And two things kind of to note with labor is if you take your entire quantity and divide it by the labor used, you get your average product of labor, so the average amount of products you make per labor. And then if you take the derivative of quantity with respect to labor, that function, then you get your marginal product of labor. And this is basically saying like, okay, with each additional labor unit, how much more quantity are you getting? On the flip side is capital. In the short run, this is fixed, so you can't change it, but then in the long run, it's going to be adjustable. And then one thing to keep in mind is the law of diminishing marginal returns. So if I'm a applesauce producer, I take in apples, I use up these productive resources, but then the more I make, the more apples I need to use because they're getting rotten, they're getting moldy. So by increasing one output, it causes kind of the other increases, or the other increase in output to diminish as you kind of get further along. So then we have returns to scales. So essentially, there's different types. So there's increasing, constant, and decreasing. So if I were to take all the inputs and double them, if my output more than doubles, then we have increasing returns to scales. If it doubles exactly, we have constant. If I take all the inputs, times them all by 2, but I get less than double the output, that's going to be decreasing returns to scale. And then two types of cost to note. One is opportunity cost. So this is essentially the cost of the next best foregone option. And this is what is mainly used in economics to evaluate opportunities. And is not necessarily just the explicit cost, but also the implicit cost of, let's say, what you could have used that land for. You have to take that in consideration. And on the flip side are the sunk costs. So these are costs that have happened in the past and that aren't recoverable. So if this cost has already happened and you can't recover it, you can't sell off that land, you can't do something else with it, it's sunk cost. And essentially just don't worry about that. As Bob Marley likes to say, don't worry about a thing because every little thing is going to be all right. So that's what you have to think about for sunk costs. And then here's just a quick kind of example of what it looks like in terms of the actual cost curve, just to visualize the increasing, decreasing, and constant returns to scale. And then similarly, but a little different, because this is now talking about cost in terms of economies of scale. So now if our output rises and our average cost falls, then we have economies of scale, which means we want to kind of go get bigger because we have less costs. And then if the cost, kind of the average cost stays the same, then we have constant costs. And then if it rises, then we have decreasing costs. Okay, elasticity. You're kind of looking at the slope. Or different types of slopes, but essentially you're just looking at how the impact of changing one factor affects the change in another factor. So how sensitive is demand to change in prices? So if we increase price by this percentage, how much percentage will quantity demanded vary? If something is less elastic, that means that it won't vary as much, versus if it's more elastic, that means that if we switch price a lot, it's super sensitive, so it'll change a lot. And there's two different formulas for this. The one, which is the point form. So if you're given a specific point, you have to find the price and quantity. And then with that, you do price over quantity times the derivative or the slope of that equation. And that'll give you that elasticity versus if it's over a range. So if it's from X to Y, you're going to have a little bit more complicated formula, but you're going to take the change in quantity divided by the change in price, and then you're going to times that by the average price. So price 1, price 2 added together divided by 2 over the average quantity. So quantity 1, quantity 2 added together divided by 2. And that's going to give you your arc elasticity formula to calculate that elasticity. And if it's greater than 1, then you have elastic demand. And this is the absolute value for demand. Elasticity is going to be negative. If it's less than the absolute value of 1, then you have inelastic demand. And just kind of keeping those reference numbers between kind of perfectly elastic, perfectly inelastic, between infinity and 0. Okay, and as you move along a demand curve, you change your elasticity. So kind of as you get higher, if you think about as price becomes higher, you get more and more elastic, versus when price is lower, it's less elastic, so it's more inelastic. And then somewhere in the middle, you have your perfectly unitary, or your unitary elastic, which is equal to 1. So just kind of keep that in mind of as you get more price, more elastic. Okay, and then really quickly, some quick stats review, because that's a little bit important. But when you're looking into calculating this demand curve, you want to look into the best fit line, which minimizes the sum of squared errors. And this is basically like the squared error is your estimated point compared to the actual data point. And then the t-statistic, which is essentially calculated from the coefficient divided by the standard error. And a larger t-stat means that it's more probable or have a higher likelihood of actually happening. And if it's larger than 2, it's statistically significant. And then keep in mind that just because we have this large correlation between two things doesn't mean that one thing causes the other. There can be a numerous amount of other factors that keep in mind. So just because there are more shark attacks when ice cream sales go up doesn't mean that ice cream sales cause shark attacks. And then if we were to change the data, bring it closer together, that'll improve our R squared, which is just a way of kind of looking at how useful the model is in a simple form. All right, let's make some money. If we want to maximize revenue, we're going to set, we're going to kind of want to operate where our marginal revenue is equal to 0. Anywhere past that, we're going to be losing money for the most part of production. But if we want to maximize profit, this is kind of the holy grail of everything. We take it where marginal cost equals marginal revenue. So the derivatives of cost equals the derivative of revenue. This is like the holy grail equation. Keep this in mind for almost all questions. If you have to figure out something, you're going to be using this equation. So just keep that in mind. That's how you're going to maximize profit. And then in the short run, a shutdown rule is if your average variable cost is higher than price, you're going to want to shut down. But then in the long run, you also have to take into consideration your fixed costs, because now they're avoidable. So if your average total cost is greater than price, you're going to want to shut down and exit the market, because you're going to be losing money. And one thing to keep in mind is if there are kind of recoverable costs, what I would suggest is just computing the total profit you would get from staying within the market and the total profit you would get from exiting the market, and go about that way just to better understand that.